Hello, time travelers and curious minds. Welcome to the portal that's about to take us on an incredible journey. A journey billions of years back in time. Picture a world before the 7 continents, a world before the diverse life forms we see today, a world still in the throes of its creation. It was a time when our Earth was a solitary sphere in the vast cosmic arena, with a single massive landmass, Pangaea. Today on HGP Wonders we'll traverse this forgotten era, uncovering the birth, life and death of this supercontinent. We'll explore how this massive land formation influenced the world we live in today. So, are you ready to embark on this fantastic voyage through time? If you are, then hit that subscribe button and let's dive right into the annals of Earth's history. Welcome back, explorers. You've tuned into HGP Wonders, your one-stop destination for demystifying the enigmas of history, geography and people. If you're new here, make sure to press that subscribe button to join us on this exciting voyage of discovery. Today we're setting our course billions of years back in time to when our home planet was in its infancy. We'll delve into the tale of Pangaea, the supercontinent that was instrumental in sculpting our world. By the conclusion of this video, we'll have witnessed the birth, existence, and demise of this colossal land formation. Are you ready? Fasten your seatbelts as we plunge into the cosmic past to decipher the narrative of our Earth's creation. Ever pondered about the birth of our planet? Visualize this, an unstable blend of gas and dust, uniting approximately 4.5 billion years ago. That's a glimpse of the nascent Earth, a molten globe of rock, continuously assailed by asteroids and comets. The Genesis witnessed volcanism, a phenomenon that molded the early Earth and its atmosphere. The surface was a churning, molten panorama with volcanoes ejecting gases and magma. But across hundreds of millions of years, the crust of Earth started to cool and harden. This cooling process was far from swift. It demanded ages for the Earth's seething surface to cool down sufficiently to form a solid crust. This crust, though delicate and thin, served as the backdrop for the remainder of Earth's geological narrative. This blazing commencement was the initial stride in the journey that would eventually culminate in the creation of our continents. In the next few minutes we'll voyage through the corridors of time from the blazing inception of our planet, the formation and disintegration of the colossal supercontinent Pangaea, to the formation of the continents as we recognize them today. So let's plunge into this journey. Scene script. Have you ever heard of Pangaea? It's the name given to the supercontinent that existed during the late Paleozoic and early Mesozoic eras. Picture, if you will, a world where land masses are not scattered across the globe as we know it today. Instead, imagine a time when all the continents we see now were snugly fit together into one giant supercontinent. That, my friends, was Pangaea. The formation of Pangaea was a slow and gradual process that took place over hundreds of millions of years. It began with smaller landmasses colliding and fusing together, driven by the force of tectonic activities beneath the Earth's surface. Now you might be wondering, what exactly are these tectonic activities? Well, beneath the Earth's crust are massive rock-like plates that float on the semi-fluid layer of the Earth's mantle. These plates are constantly moving, albeit at a pace slower than the growth of human hair. But over millions of years, these small movements can result in significant changes in the Earth's surface. This phenomenon is known as plate tectonics. The concept of plate tectonics is also the driving force behind the breakup of Pangaea. Around 200 million years ago, the same tectonic forces that brought the continents together started to pull them apart. This breakup was not a single event, but rather a series of splits that occurred over a vast stretch of geologic time. First, Pangaea split into 2 large landmasses, Laurasia and Gondwana. As time went on, these 2 continents further fragmented into the continents we know today. The slow drift of these continents is still ongoing, shaping the face of our planet as we know it. Pangaea's existence and subsequent breakup has been supported by compelling evidence from various scientific fields. This evidence, which we'll delve into in the next scene, has given us a fascinating glimpse into the dynamic nature of our planet and its impressive ability to reshape and reinvent itself over time. So, stay tuned as we uncover the captivating story of Pangaea and its lasting impact on our world. But how do we know Pangaea existed? What evidence supports this theory? Let's delve into the compelling evidence that has led scientists to the conclusion that our continents were once part of a supercontinent called Pangaea. First off, the jigsaw-like fit of the continents is hard to overlook. Just take a glance at a world map. Notice how South America and Africa seem to nestle together like 2 pieces of a puzzle? Well, that's no coincidence. The continental drift theory proposed by Alfred Wegener in the early 20th century, suggested this snug fit as evidence of the continents once being joined together. However, the story doesn't stop there. Fossil evidence provides another compelling piece of the Pangaea puzzle. Certain prehistoric plant and animal fossils like the fern Glossopteris and the reptile Lystrosaurus have been found on multiple continents, including ones that are now thousands of miles apart. It's highly unlikely these species swam or flew these vast distances. The more plausible explanation? These continents were once neighbors in the supercontinent of Pangea. Further evidence is found in the rock formations and mountain ranges that span multiple continents. Take the Appalachian Mountains in North America and the Scottish Highlands, for instance. These two ranges share striking similarities in their age, structure, and even the types of rocks found within them. The most logical explanation? They were once part of the same mountain range when North America and Europe were joined in Pangea. Lastly, we have climatological proof. Ancient glacier scars and coal deposits found in regions that are now tropics provide evidence of dramatic climate changes. These changes align with the shifting positions of the continents over millions of years. So, from the fit of the continents to fossil evidence, rock formations, and climatological proof, the evidence pointing towards the existence of Pangea is compelling. It paints a picture of an Earth that was once very different from the one we know today. The evidence is clear. Our continents once formed a single, unified landmass. So, what happened to Pangea? Why did it break apart? Well, the answer lies in the fundamental dynamics of our planet. You see, the Earth is not a static entity. Beneath our feet, the Earth's crust is divided into large pieces called tectonic plates. These plates are in constant motion, albeit at a pace slower than the growth of your fingernails. About 200 million years ago, these tectonic plates started to move in a way that would forever change the face of our planet. The supercontinent of Pangaea, which had been a single landmass for millions of years, began to crack and splinter. This was the beginning of the breakup of Pangaea, a monumental event that would take millions of years to unfold. As these tectonic plates moved, they carried the continents with them. Picture this. You're on a raft in the middle of the ocean, and the current starts to move you. That's what happened to the continents. They were on top of these tectonic plates, and as the plates moved, so did the continents. Over millions of years, these slow but relentless movements caused the continents to drift apart and form the familiar configuration we know today. But the breakup of Pangaea wasn't just about moving continents. It also created new ocean basins, mountain ranges, and rift valleys. It changed the climate, altered ocean currents, and even had an impact on the evolution of life on Earth. For instance, as the continents split and moved towards the poles, they took with them their unique ecosystems. This led to a diversification of species, as life had to adapt to new environments. It's amazing to think that the movement of the Earth's tectonic plates could have such a profound impact on the evolution of life, isn't it? In conclusion, the breakup of Pangaea was a pivotal moment in Earth's history. It reshaped our planet, creating the continents and oceans we know today. But it also played a crucial role in the development of life on Earth, driving the diversification and adaptation of species. The breakup of Pangaea radically changed the face of our planet, but it also had far-reaching effects on life on Earth. How did the breakup of Pangaea affect life on Earth? Let's dive into this fascinating chapter of Earth's history. When Pangaea started breaking up, it set the stage for a grand evolutionary experiment. As the continents drifted apart, species that had once shared a common landmass found themselves in different environments. This geographical isolation led to the evolution of new species as organisms adapted to their unique surroundings. Just imagine, the kangaroo hopping around in Australia, the polar bear in the Arctic, or the toucan in the Amazon. Their existence can be traced back to this grand continental drift. Each of these species evolved to fit perfectly into their respective ecosystems. But the breakup of Pangaea did more than just influence the evolution of species. It also played a crucial role in the formation of different climates across the globe. As the continents moved, they disrupted ocean currents and wind patterns, leading to the development of diverse climates. For instance, the movement of Antarctica towards the South Pole resulted in it becoming isolated from other land masses, leading to a drop in temperature and the formation of the Antarctic ice sheet. This had a profound impact on global climate, influencing ocean currents and wind patterns. In addition to shaping the climate, the breakup of Pangaea also led to the development of distinct ecosystems across the globe. The formation of mountain ranges, such as the Himalayas and the Andes, influenced rainfall patterns, and created unique habitats for a wide variety of species. Moreover, the creation of new coastlines and the formation of shallow seas provided ideal conditions for coral reefs to flourish. These reefs are now home to a quarter of all marine species, showcasing the immense impact of Pangea's breakup on life on Earth. So the next time you marvel at the diversity of life or the variety of climates on our planet, remember that these are not merely the product of time, but also of the dynamic and ever-changing nature of the Earth itself. The breakup of Pangaea not only shaped our physical world but also the biological diversity we see today. From the evolution of diverse species to the formation of distinct climates and ecosystems, the breakup of Pangaea has indeed shaped life on Earth as we know it. But what about us, Homo sapiens? How has this continental drift influenced human civilization? The answer is, profoundly. As we know, the first humans originated in Africa. As the continents drifted apart, humans began to migrate, exploring new lands. The continental drift created natural barriers like mountains and oceans, which shaped the migration patterns of early humans. These barriers also led to the isolation of human populations, which in turn resulted in the development of distinct cultures and languages. Take for example the indigenous tribes of Australia and the Native American tribes. Both evolved in isolation due to geographical barriers, resulting in unique cultural identities. Similarly, the formation of different climates across the globe played a significant role in shaping human societies. For instance, the fertile land around the Nile River in Egypt, resulting from the continental drift, allowed an early civilization to flourish. Furthermore, the breakup of Pangaea led to the formation of rich mineral deposits in various parts of the world. These resources have been instrumental in the development of human civilization, driving technological advancements and shaping the economic and political landscape of our world. Indeed, the imprints of Pangaea's breakup are all around us, in the languages we speak, the cultures we celebrate, and the resources we extract. It's a testament to the interconnectedness of our planet's geological history and our own human story. Before we move on to the present-day continents, let's pause and reflect on the legacy of Pangaea and what it might mean for our future. The continental drift didn't just shape our past, it continues to influence our present and will undoubtedly impact our future. Today, scientists use the principles of plate tectonics to predict future continental movements. Current projections suggest that the continents will continue to drift, potentially leading to the formation of a new supercontinent hundreds of millions of years from now. Some scientists propose that this future supercontinent, dubbed Pangaea Proxima, will form through the closing of the Atlantic Ocean as America and Africa move towards each other. But remember, these are just predictions based on current data and trends. The Earth's crust is a dynamic and complex system, and many factors can influence its future state. The legacy of Pangaea is a constant reminder of our planet's dynamic nature. It's a testament to the ever-changing, ever-evolving nature of our world, and it leaves us with the question, what will our planet look like in the far future? Whatever the answer may be, the story of Pangaea teaches us that change is the only constant in the geological history of our planet. So, how did we get from Pangaea to the 7 continents we know today? Well, let's take a quick journey through time. When Pangaea started to break apart about 200 million years ago, it didn't just split into the continents we see today. It was a slow process, with landmasses shifting, colliding, and separating over millions of years. First, Pangaea divided into 2 large landmasses, Laurasia in the north and Gondwana in the south. As time marched on, these supercontinents further fragmented. Laurasia split to form North America and Eurasia, while Gondwana gave birth to South America, Africa, Antarctica, Australia, and India. Over the eons, these continents drifted to their current positions. And it's not over yet. The continents are still moving, albeit at a pace slower than the growth of your fingernails. And that's how our continents have been shaped over billions of years, from the fiery birth of our planet to the world as we know it today.